Olá a todos, muito bem-vindos à nossa palestra de estreia da disciplina de seminários da pós-graduação do IB. Eu estou falando da pós-graduação porque nós estamos com estudantes aqui de pelo menos 6 programas diferentes do Instituto de Biologia. E estamos experimentando, né, essa nova modalidade de fazer essa disciplina. Os alunos matriculados já sabem que tem que se inscrever na plataforma Moodle, né, e tem que fazer uma tarefinha após cada conferência, onde eles vão colocar suas impressões. Gostaria de lembrar que todos podem direcionar as perguntas pelo chat. Nós temos uma equipe que estará coletando essas perguntas e nos passando para que a gente passe para o Dr. Arturo Casadevall. Essa é uma estreia em grande estilo, estamos talvez com um dos maiores cientistas na área de imunologia, de doenças infecciosas, e é um grande prazer. E ninguém melhor do que a professora Ana Amélia para apresentar o Dr. Arturo, a quem eu passo a palavra agora. Aproveitem bastante o nosso evento.
Okay, today our speaker is Dr. Arturo Casadevall. He is a microbiologist and immunologist, and during this last year, he is an important collaborative researcher of UNB, opening his laboratory for students and professors. His biography is remarkable. Briefly, he has received his MS, PhD, and MD from New York University. He has completed the postdoctoral fellowship at the Albert Einstein College of Medicine. He worked at this institution from 1992 until 2014. And in 2015, he moved to Johns Hopkins University. He is a Bloomberg Distinguished Professor and the chair of the Department of Johns Hopkins Bloomberg School of Public Health. At Johns Hopkins, he has accepted the challenge of improving the PhD program, changing the way of scientist formation and training. He is an international recognized expert on fungal pathogenesis and the basic knowledge of antibody structure function. About the fungal pathogenesis, he is the main focus and study of Cryptococcus neoformans and its interactions with different hosts like amoeba, Galeria, and mammals. Today, his lecture is about antibodies. His study of antibodies started with his PhD, and now he has a vast and essential number of publications about it. So thank you, Arturo, for accepting our invitation to speak to us. It's a huge pleasure.
Thank you, Ana Amelia. Thank you for that very nice introduction. So I guess, do I share the screen now?
Okay.
Is it all okay now?
Okay.
So the title of this presentation is something new for me. I mean, I wasn't working on any of this until about 4 months ago, but it is the convalescent plasma therapy for COVID-19. And I think the first thing is to just say, what is convalescent plasma? Convalescent plasma is the plasma when people recover from an infectious disease. Plasma is the liquid part of the blood. It holds the cells. So if you take blood and you centrifuge it, you will see you get a buffy coat, you hear the red cells, and this is the plasma. When people are in the convalescent phase, they have antibody in the convalescent blood that can be used for therapy or for prevention. It is important to think that this differs from a vaccine because in convalescent plasma, you give antibodies from somebody else. When you get a vaccine, you have to make your own antibodies. So the way this works is relatively easy. You draw the blood, you make the plasma, and you give it to people that are already sick, or you give it to people that may have an exposure and have a chance of getting the disease. It's important to know that the antibody story is old. This began in 1891 when these two individuals did a remarkable experiment they showed that you could transfer immunity with immune sera to diphtheria or tetanus toxins. This is one of those simple and critical experiments that changed everything afterwards. It led to the growth of immunology. It eventually led to the discovery of antibodies, although it will take many, many years, decades, before they knew that antibodies were proteins and how they were, and we didn't really know how they were generated up until 80 years later. The first Nobel Prize in medicine was given to Emil von Behring, and in reality should have been given to Shisaburo Kitasato also, making the first Nobel Prize controversial. All the Nobel Prizes are always controversial in some way. But it was the first time that physicians could alter the course of an infectious disease. And here you see something from Scientific American 3 years later, in which a child is already being treated with serum. And this worked. In fact, at the time, this was miracle therapy. Children with diphtheria is a horrible disease. We're lucky we don't have to see it anymore because we now have toxoids that prevent this. But children asphyxiated with a membrane at the back of the throat, and the only way to treat them was to do a tracheostomy. But when they gave them the antibody, the membrane will dissolve, often very rapidly and in front of the eyes of the physicians. The antibody was used then for the therapy of many infectious diseases. And you can see from this that I've been interested in this subject for a very, very long time. But it reduced pneumococcal pneumonia by about 50%. Today, the mortality of pneumococcal pneumonia with antibiotics is about 10%. So you could see the enormous gain that was made with just using serum. And meningococcal meningitis by about the same. And many companies began as companies making these type of compounds. So the antibody sources at the time were either animal or human. So if you could grow the microbe, for example, a bacteria, you could make a toxin, you could immunize an animal, and then you could have large amounts of serum. And people use horse, rabbit, and even chicken to make antibodies. And so animal sera was used primarily for bacterial diseases, such as pneumococcal pneumonia, erysipelas, meningococcal meningitis, anthrax, etc. Human convalescent sera was used for viruses. They didn't know how to grow viruses. They didn't have cell culture. So they had to wait for an epidemic to happen. And then the people who recovered first became donors. And this was then used to treat those who came afterwards. But it was used, for example, when there were outbreaks of polio, they would take the blood from the parents, assuming that the parents would have antibodies. And it was used primarily for viral diseases. The problem was always supply and logistics. You don't know when an epidemic is coming, so you can't prepare for it. But it was used, and I'll give you some more examples of that. They had no knowledge of blood-associated diseases like hepatitis. And in fact, this was abandoned in the 1950s when it was discovered. Things like hepatitis were discovered. So if you look at antibody therapy, the heyday was between 1900 and 1940, and all these diseases were treated with antibodies. And then with the introduction of sulfonamide and penicillin, this rapidly declined. The antibodies continue to be used in some niches, like vaccinia, immunoglobulin, rabies, immunoglobulin. If you get bitten by a rabbit animal, today you still get antibody, but this is a small part of the infectious disease arsenal. A couple of monoclonal antibodies have been licensed in recent years, but most of the antibody therapies today are used in oncology and in rheumatology. And this is a problem. And this is a problem we had here in the United States, that the doctors didn't know how to use this. And it's taken a lot of education in the last 4 months. So what are the lessons from history? The lessons from history are that antibody is effective for the treatment of infectious diseases, that efficacy depends on timing, that the earlier you give it, the better the result, that the efficacy requires a certain amount. You must give a certain amount of antibody to get a result, that these were well tolerated, that recovery was rapid. In fact, for pneumococcal pneumonia, recovery was faster than with penicillin. And the reason for this is simple. when you give an antibody preparation, you neutralize a lot of things, microbial antigens. So people felt better right away because it's the microbial antigens that lead to cytokine release and things like that that make you feel ill. But antibody therapies were abandoned largely in the 1940s. For bacterial diseases, they were replaced by antimicrobial therapy. And for viral diseases, there was the concern about hepatitis and bloodborne illnesses. Here is, for example, data from 1913 from Flexner on the treatment of meningococcal meningitis. And you could see that when you look at the percent recovered, it rises. It's very much dependent on when you use it. On the first to third day, 82% recovered. But if you wait till the seventh day, the recovery rate is only 63.5. So one of the important rules is if you're going to use antibody, you use it early. You don't think about it, you order it and you use it. How do antibodies work? Antibodies work with many different types. They have a lot of mechanisms. For COVID-19, we are primarily interested in viral neutralization, but you also have the phenomenon of ADCC. You may have complement activation, this is an envelope virus, and immunomodulation is likely to also be very important. So one important theme is that when you give a unit of plasma to a patient, you're giving a lot of different activities, from viral neutralization to activation of complement. And this is important for how we begin to look at how this works. Convalescent plasma was used in many past epidemics. It was used in the 1918 epidemic. It was used in outbreaks of, for example, measles, and I'll tell you more about this in a minute, and for mumps. As late as 1946, in the United States, people were trying to stop an epidemic by giving plasma. So here are some of the major uses. 1918 in the influenza epidemic, from the 1920 to 1940 outbreaks of polio, mumps, and measles in the United States. In the 1970s, it was used in Argentina. One of the best controlled trials of plasma was done in Argentina, and it showed that it greatly reduced mortality from Argentine hemorrhagic fever. In 2003, it was used with SARS coronavirus in Hong Kong. In 2012, it was used with the H1N1 influenza epidemic. In 2012, it was used for the Middle Eastern MERS, which is another coronavirus. And it was also used in the Ebola outbreak in West Africa. And the reason use of the Ebola outbreak in West Africa is mixed. Some people reported that it works, and some people reported that it didn't work. But when you look at it, the one common denominator appears that they used it in patients who were very sick. And if you want to get efficacy, you give it early. If you give it by the time these people are having symptoms, it's unlikely that the antibody will be able to be used. And now, in 2020, it's been the biggest, at least in the United States, the biggest application of plasma in the history of, and I'll be telling you about that in a minute. So this is data from 1918. And what you can see is that when patient responded, the response was rapid. Here is a soldier, and here is the fever. And what is interesting to look at is look at the respiratory rate. This individual gets into trouble here. His breathing at 56, and they give him serum, and you can see that it rapidly gets better. And in fact, the recovery is within a day or so. So an important, again, when it works, it tends to work quickly. A meta-analysis of the 1918 epidemic showed that, in fact, it reduced mortality. This is individuals went back and looked at all the data that was published at the time and concluded that the administration of serum, in those days, they didn't have plasma. They had serum. So when you look at the old literature, it's called serum because they let it clot and then they took the liquid. Today, we don't let it clot. Today, we use plasmapheresis and remove the plasma. And the plasma differs from serum in that it has clotting factors. But in terms of antibody, it's the same preparation. So with serum, they were able to reduce mortality by about 50%. In 2009, also reduced mortality from about 55% to 20%. This is the outbreak of H1N1, which was the last global influenza pandemic. And here is another paper, again, showing So the important thing is that over 100 years, we have a lot of experience with this. And the one thing that emerges is it works, but you have to get it early. So what is the evidence for convalescent plasma and coronavirus disease? There was one major study from Hong Kong. 80 patients were treated. And those that received it early, there was a much higher discharge rate, which means a much higher survival rate between 58% versus 15%. And MERS coronavirus, there has been anecdotal use in Saudi Arabia and in South Korea. It appears to be well tolerated, but the problem is that the cases are too sporadic, so there hasn't been a major study. So let's talk about the deployment of convalescent plasma for COVID-19, and I'm going to be telling you primarily about the American experience here. So in January, I was very worried about what was happening. I'm an infectious disease doctor, and once I saw that they had locked down Wuhan, I felt that this was not containable. I knew the history of antibody-based therapies because I'm interested in history. I think that everybody should be interested in the history of their field. And I spent a lot of my time reading about what was done in the past. And I was very worried that nobody here in the United States was talking about plasma therapy. They were talking about vaccines, they were talking about antivirals, they were talking about all kinds of brand new therapies, but the word plasma was not in the vocabulary of any of the health authorities. And I wanted to get the word out. And, the question is, how do you get the word out? Well, I could have published it in a journal, but who cares? You needed to get it out into the public. So I spent most of February looking for a newspaper that would publish an op-ed. And the New York Times didn't want it, the Washington Post didn't want it, but the Wall Street Journal published it. And what I decided to do was to focus on one incident that I knew about, which was how one doctor was able to stop an outbreak. I figured that this was pediatrics, that this was prophylactic use, and that this will catch people's interest. And here's the paper. This was in 1934, there was one child got measles in a preparatory boys' school, and there were 66 that had not had measles. So the doctor was very worried that there was going to be an outbreak. So what the doctor did was he waited for the boy to recover and then took blood from the boy and gave it to the others. And they were expecting 25% of this group, and they only got 2 cases, and they were mild. And this shows you, in this case, 10 milliliters was sufficient to stop an out per person, to stop the outbreak. So this is what happened here in the United States. This is the Wall Street op-ed was published, and I sent it to all my friends. And who are my friends? People in the field. This is, I organized here at Hopkins a group, and we began to look at the possibility of doing this. However, I realized that an op-ed is not enough, that you need to have a paper that has references and has ideas in it. So I began to work with Lisanne Porosky, and we very rapidly wrote a paper that I'll tell you about, and that was the journal had it reviewed in one day, revised and published pretty much the next day. And then a national convalescent plasma project was organized here in the United States. And within 3 weeks, we were allowed to use plasma, and the first patients were treated in March 27. So 4 weeks between idea and treatment. This is the leadership of the group. We immediately began to put out information. We got no government help. We were able to, however, industry stepped in, and Amazon built for us the website. They donated labor, and this has been the story of the plasma project in the United States that is largely being driven by physicians with local resources, because up until very recently, there was no major support. So it's interesting. So Michael Joyner from the Mayo Clinic stepped in. He's an anesthesiologist. And Nigel Panes had the website. So one of the important things with the website was to put in all the information we had so that the world could take it. All the protocols, all the papers, And this site then became organizing, and it allowed other countries to develop plasma. And today, dozens of countries, including Brazil, are using plasma. Here are some of the major actions by the Food and Drug Administration in the United States. Compassionate use was allowed, and we were granted within a week later or so to be permission for clinical trials in high-risk individuals. However, the FDA came under tremendous pressure to allow it to be used earlier. And they, on April 8th, relaxed the rules such that the doctors could make the determination for when it should be given. And it becomes a very important decision because, as I'm about to show you, in the early days, all the use was on people who were very sick and dying. And today the use has moved much earlier. And this is associated with a reduced mortality. So who can take it? You have to be 18 years old. You need to have a diagnosis. This was limited to hospitalized patients. It needed to have severe or life-threatening COVID or judged by the physician to be at high risk of progression. This wording becomes critical because it allows people to be treated early. If you worry that somebody's going to go forward and end up in the intensive care unit, this wording allows you to order the plasma earlier. The Mayo Clinic holds the investigation on new drug. This is the regulatory system in the United States in which you have to have an entity that holds this, and then plasma use in the United States grows exponentially in April. By the mid-April, we had over 1,000 sites using it. Today, we have about 3,000 sites. These are the two publications. This was the original one that I called the manifesto, in which we just put out all these references and all this stuff for people who didn't know. But we immediately realized that you needed more than that. You needed to have a how-to guide, because you may know what happened in 1918 may be useful for writing a protocol, but you also got to know what we call the nuts and bolts, what the key steps on how do you set it up at your hospital, how do you recruit patients, what kind of patients you take. And then this paper appeared a couple of weeks later from two of our transfusion people here at Hopkins. So around this time, China was beginning to report the use of plasma. And the initial reports, this is early April, JAMA, 5 critically ill patients, and then there was another paper in PNAS of about 15. These were not clinical trials. These were case series, but they become very important because a lot of the big concern in the early days was whether by giving antibody, you would trigger the phenomenon of antibody-dependent enhancement. Or, as people would say to me, you're going to give them antibody, you're going to cross-link Fc receptors, and you're going to trigger a cytokine storm. And you're going to make things worse. And I was pretty sure it wasn't going to happen because in history, there was no precedent for that. There was no precedent for giving somebody 1918 plasma and the doctors writing that they got worse right away. But still, we were worried about it. I think you always have to be cautious in not hurting people. This is some of the data on the PNAS paper. And even though it's messy, I think you can see that the markers, C-reactive proteins, tend to go down on most patients. And interesting, the saturation went up. But what was clear from the early papers was that plasma was working as an antiviral. All the Chinese papers were reporting that after plasma was given, that they could no longer PCR the virus. And that is very important because it means that it's working as an antiviral agent. They also reported radiologic improvements. I mean, this is stuff taken from their paper. You can see they're anecdotal, but it was encouraging. Italy began to report that convalescent plasma was effective. And initially, all we had was newspapers. But I know enough Spanish to say that this sounds like the therapy is functioning. And I'm sure from Portuguese, you can probably make up that this sounded like good news. And in fact, it's taken a couple of months, but the Italian data is now out. And they, in fact, were reducing mortality quite a bit. So the situation today is this slide. We're up to 30,000 patients treated in the United States. You have national and international networks emerging. Convalescent plasma is being used in many other countries. The convalescent plasma supplies are increasing. Early in the epidemic, there was a major problem of getting enough plasma, but now there is sufficient. And now, as you have seen what's going on in the United States, the number of cases here is incredible. We have a real problem. And for example, yesterday, 1,000 people were treated with plasma in the Southwest. The hyperimmune globulin is in development, and there are numerous clinical trials ongoing. So it's important to think that we are using a lot of plasma. So 30,000 patients have been treated, but there are also randomized clinical trials happening at the same time. How we're doing that? Well, I'll give you a sense of that. So what are the two big questions? Is it safe and is it effective? So the risk and safety. So we have to first think about known risks. What are the known risks of plasma? Well, sometimes you get a transfusion reaction, even though plasma is typed, and if you're type A, you get a type A plasma. There are minor antigens, and sometimes when people get infused with plasma, they get a reaction. This happens. It can be treated. You can. It's not a life-threatening, but it's something that you want to avoid if possible. Of greater concern is something known as transfusion-related lung injury. And this is a phenomenon where you see it when you give a lot of plasma. Often there are antibodies that can cross-react with the lung, and they can give lung damage. And there was a great concern about this because these patients all had, as you know, lung disease. There is something known as TACO. These are great names, Strali and TACO. Transfusion-related volume overload. And what happens is that you have a patient and you infuse them with plasma, you're giving them a colloid. And if they happen to be you could trigger them into volume overload, and that will worsen oxygenation, and it will worsen the cardiovascular system. And there is always the concern about bloodborne pathogens. You screen for HIV, you screen for hepatitis B, hepatitis C, but you never know. There occasionally something can get through. And then there were the theoretical risks. Many people were worrying about an antibody pro-inflammatory reaction that I mentioned. The idea that antibody will trigger a cytokine storm, and then antibody-dependent enhancement. This is a phenomenon that there was great concern because there are multiple. If you look in PubMed and you put coronavirus ADE, you will see all the papers come up. And I got my folders full of emails of people warning me that this was a danger. But I was pretty sure that if you recover from COVID and you are well, that I cannot imagine the antibodies that made you recover would trigger antibody-dependent enhancement. That didn't make any biological sense to me. So I was not as worried, but I could tell you that when the first patients were treated, I was relieved that there didn't seem to be a lot of problems. So we even carried out risk-benefit analysis, and we felt that the benefit outweighed the risk for all the groups. So the first question is it safe? And I'm happy to tell you that yes, it is as safe as plasma. The first paper was published last month. You know, everything is happening extremely rapidly nowadays. And the first 5,000 patients, there were really no major issues. And now we're reporting on 20,000 patients. And you can see that that TACO, which is the circulatory overload, is in 0.2%, which is very, very small. These are very ill patients. And so the incidence of transfusion-associated problems is in fact very low. And that's maybe an overestimate, because since these patients are so sick, they're often in the intensive care unit. Anything that happens in the next 6 to 8 hours gets considered to be a side effect of the plasma, even though it may not be related. But at least from the safety point of view, it looks like we are in a good place. Here is some data that was published, and it shows you what's happening in the United States. This was the first week of April, and the mortality of all the patients treated with plasma was about 15%. This was the middle of June, 7 weeks later. And that I don't know, I can't count. 7 weeks later, maybe early June, is down to 5%. There has been no other therapy introduced during this time. What we think you're looking at here is that the doctors are learning how to use it, and they're using it earlier. So whereas most of this use was in patients who were very sick and they gave them the plasma because they didn't have anything to do, this is happening now is that they're being treated earlier. And however, if you look at this number, 15%, this is much lower than the mortality of any group in the United States that is hospitalized. So we think that even in the early days, we were seeing a mortality effect. Does it work? Well, in the United States, the media has been full of what we call anecdotes. We now call them Lazarus effects. You know, Lazarus in the Bible that was brought back from the dead. Here is an example taken from a phone text message from a physician who contacted us. Good story. We had a relatively healthy 50-year-old guy on 60 liters of oxygen, wanting to give him convalescent plasma, but he was delirious. So his brother, who had power of attorney and wanted to think about it, had to intubate the guy. Then the brother gave, okay, we transfused it, and he was extubated 24 hours later last night and room air. Look, this is an anecdote. This is not clinical data, but I'm showing it to you to give you a sense of what began to happen. You began to get cases like this, and when you get one, it's an anecdote. When you get 100, you begin to think, gee, maybe there is something to this. However, I don't consider this very, important clinical data. I'm just sharing it with you to tell you that in the early days, we began to get encouragement. So case series show reduced mortality. History provides optimism, and ongoing clinical trials. We have here at Hopkins prophylactic use and early therapeutic use. These are randomized controlled trials where nobody knows what is in the plasma. These prophylactic use are for people who get major exposures. The early therapeutic use are for people who are at home, sick. And the question is, if you give them a unit of plasma, do you prevent them from getting worse? And then we have late therapeutic use and even a pediatric protocol. This morning, I learned here that there is a child who's getting a kidney, a 21-month-old child who's getting a liver transplant. And one of the issues, and has COVID-19. So the child is dying from the liver, so they have to transplant it. And what they're doing is they're using convalescent plasma in two ways. One, to provide clotting factors, while at the same time as an antiviral. And I'm sure this case is going to end up getting written up sometime. But it is an example of how this plasma is beginning to be used in ways that no one anticipated is used previously. Here is data that I collated for when I put this talk together. And you can see this is 6 control case series. Now, what is a case series? What it means is that physicians collect number of cases. For example, in New York City, 39. In this study, 139, and they build 138, and they build controls. You look at people who got it, and you look at people who didn't get it, and you try to control for them. It is not a randomized controlled trial. But what you can see is that they consistently reduce mortality. In these 2 studies, the reason it's 100% is because it was used very early, and all the patients got discharged. They saw no death. And one of them has now been published, and this one has been published, and the other one is still in a preprint. But all these preprints are available, and if you're interested in this, it's all in the internet. So one randomized controlled trial has been published. This is from Wuhan. They ran out of patients, so they had to stop the trial. They originally planned for power, they needed 200 patients. They could only enroll about 100. So they could make no mortality conclusions. But you can see that patients treated with plasma before the ICU showed a marked improvement. This is before the ICU, and this is after the ICU. ICU means intensive care unit. So before intubation, they were able to demonstrate significant improvement. After intubation, they weren't able to demonstrate it. And this effect, by the way, is comparable to remdesivir. So what is my opinion on efficacy? In this, I'm just sharing with you what I think. I think that there is very strong precedents based on history. I think we have 130 years of knowledge about antibody. We know what things antibody can do. So you at least have a theoretical foundation to understand that if you give antibody to a person who doesn't have antibody early in disease, that this antibody can do all kinds of things to help the immune system. You have encouraging signs from case studies with matched controls. I showed you that data a couple of slides ago on one randomized clinical trial. I'm also aware of a lot of information that is going to be coming out in the next month or so. And I can't talk about that, but it does affect what I think. So if you ask me in March, will this work? I would have probably said to you, maybe, because, it's a new virus. You can't really tell, but probably it may work. In between April and May, I changed it to possibly, as some of the information began to coming out. In June, last month, and today I would have said to you, probably, yes, probably it is working. However, I won't say definitively until we get better data. So I think today, the one thing we can say is it's probably working and it's relatively safe. So what are the kind of near and far horizons? I think here in the United States, we're going to be using convalescent plasma for the rest of the year. I don't see any of the other therapies coming in fast enough to replace it. Hyperimmune globulins are being made, but it's going to take a while for there is a sufficient supply to treat the thousands of patients that have been treated. Monoclonal antibodies are going to be potentially very important. Some of them already are in clinical trials. And assuming that they work and that they work well, I think the big issue there is going to be increasing production such that one can have sufficient supply for the patients. We heard yesterday here in the United States that the Pfizer vaccine is eliciting neutralizing antibodies and is moving to phase 3, and that Pfizer is planning to make 1 billion doses by the late this year. So I had a faculty meeting with my department today, and people are having a hard time with isolation and the fact that everything that's going on. So I said to them, we have been through 4 months of this. We're halfway there. I think that probably there will be a vaccine later in the year. From all I know and the analysis of all this plasma, people are making neutralizing antibodies. If you can make neutralizing antibodies, this is likely to be able to be protective against COVID. And I'm an optimist. I think that humanity is having a really rough time. We are all on this, whether you're in Brazil, the United States, or other countries. Some countries are doing better than others. But this is a common shared experience. And I believe that, in a year or 2 years, this will be controllable. And I'm hopeful that we can do to SARS coronavirus 2 what was done to SARS coronavirus 1, which was ultimately eradicated from the human population. So with that, I'm happy to stop and take questions. Whoever, you can probably just put them in the chat box, and then Amelia may ask me about them. So I'm going to stop sharing the screen, and I'm back.
Thank you, Arturo, so much. It's a very nice talk, and we have some questions for you. The first of all, I think that what you show us is how the history of science can be used nowadays, because all this knowledge that everyone saw during all these years, you could use now for this disease. So it's amazing how to use this and how it's working now. The first question that you have, it's about the title of the antibodies. What is the neutralized antibody cutoff to say that that serum is good or not? And what is the better period after recovering to take this serum?
So that's an excellent question. We have a paper that we just put as a preprint here from Hopkins that you could look at it. I thought the talk was at 4 o'clock, so I was going to add those slides.
Okay, no
But
problem.
at least the preprint is there. You could look at it. So here's the story. In the United States, the guidance is to use a titer of about 325 or better. That's an ELISA titer. What we are finding is that people vary tremendously when they recovered in the amount of neutralizing antibody. We have people with neutralizing titers of greater than 1 to 2,500. You have to dilute the sera more than 2,500 to lose the neutralizing capacity. And you have people recovering with antibody titers of less than 1 to 80, and they are fine. So I think the problem with titer right now is that all the assays are focused on very small part of the spike protein, and that we are not, for example, measuring antibody-dependent cytotoxicity and all the other things that antibody does. So some people are recovering with neutralizing antibody, other people are recovering with other antibodies that are not neutralized. They're both fine. And the question is, which one is better for plasma therapy? And I think that we are going with the idea that since we know that neutralizing antibody is an antiviral, that it would probably be a good idea to use that. But we hope, today is July 2nd. We hope that by the end of July to be able to, that the US government will be able to put out some guidance on what is the titers that are more likely to be effective. Because all those 30,000 people, we know what the titers that went into them, we know what is happening, and that data has been analyzed. And I can't say anything because of confidentiality issues, but I think that there is going to be very good data to guide the future use of plasma.
Yes, I think that a guide will be good for normalize all the hospitals use. The other one is, do you think that after the establishment of a pharmaceutical treatment or a vaccine for this disease, the plasma therapy will still be important in some cases, or they will use the only specific cases for some patients or some disease?
So, Amelia, that's a really good question. I originally thought that things were going to move faster. I thought that by July that we will be not using plasma. But the problem has been that making the gamma globulins just takes a long time. And so I think we're going to be using plasma therapy for a while. But you're asking me actually something that I've been thinking a lot about. Before March, here in this country, there was no idea of using convalescent plasma for anything. Now it is. So what we're hoping is that we can move from this to use it against influenza. Every year, there are 80,000 deaths in the United States from the flu. Imagine that now that we know how to use it, we can also use it in influenza. And maybe we can reduce mortality. And then convalescent plasma, now with the knowledge that we can screen for hepatitis, for HIV and all that, can again be a standard therapy for many diseases.
Probably it came to be a possibility for the treatment, not only for COVID-19.
That's right. That's right.
Okay, let me see. Do you, for this serum, do you use a pool of serums, or it's one patient for the other patients?
When one donor gives 2 to 3 units.
Okay.
So we are not pooling it in any way. You basically make a unit and then you use it on a patient after you do the screening. So the good thing is that people that are good responders and who we now know who they are can donate antibody every 2 weeks, because you can do plasmapheresis every 2 weeks, and every person can help 2 to 3 people.
And this is my question, because when I teach, I talking about the idiotype network that is important to regulate. Did you see any information that you think that the levels of antibodies decreasing considering the idiotype network?
Yeah, I think it happens. It happens with every disease that, you have an antibody boost and then you go down. But the one thing is, we know we have memory. And if you get infected again, that's how we get it. It looks like the highest antibody titers are about at 4 weeks. after people get better. And then they decline a little bit, and they decline slowly. We don't know if it's going to go down to zero, but I'm not too worried about reinfection, because if you resolve it the first time and you make neutralizing antibody, I suspect that you have some degree of immunity.
Okay.
Amelia, can I make a question too? It's mine. Actually, I was thinking about the logistic of doing this. Do you have to make a titration to see neutralization of these donor plasmas? Is that important? And how do you do this?
So in the early days, back in March, what we thought of getting people to donate a sample, titrate them, and bring them in. But what we found is that the most effective thing is to get people to donate. Okay. And then once you have the plasma, to do the titer. And if you have low plasma titer, that can be used for other things.
Okay.
Plasma is still good. It can be used for surgeries and things like that. And if you have high titer, then you use it. Because I think it's too hard to ask somebody to come in, to take their blood, to check their titer, to send them home, and to bring them back again. You might as well bring them once and take the plasma.
But you test the neutralization before give the plasma to a patient, for example.
But 80% of the units are good. That's important. 80%. So if you can't test it and you're in a situation in which you have a calamity, I think it's okay to take it and use it, because the likelihood is that most units are going to be fine. Or you can do 2 units, because if you give somebody 2 units, then you're much more likely from 2 different people to have given them enough antibody.
Okay. Amelia?
How much is considered very early? Because many people, in fact, it doesn't show any of the light and the common symptoms. How does it complicate the use of the therapy?
So when I think very early, I think that when people that get admitted to the hospital are admitted because they are sick. They're short of breath, they have fever, and they often have the beginning of pneumonia. My advice is that if plasma is going to be used, it should be used very early after admission. The question you're asking is, what happens to people sitting at home? Will they benefit? Well, we have a clinical trial going on here, multi-center, which we hope will give us an answer by August, in which you take people sitting at home and you give them either convalescent plasma or plasma before COVID-19 that have been in the refrigerator. And you ask the question, what happens? And based on everything that we know about antibody, I suspect that those that get convalescent plasma will not progress. They will just get better.
Is the use of plasma therapy capable to affect the development of host natural immunity, especially the long-term immunity to the pathogen?
So that's another concern. If you give somebody antibody, will their immune system response be weaker? It's a theoretical concern. I think that you're dealing with a disease that is very nasty. That even people who are not killed, who don't die, have a lot of side effects. We're now hearing about psychiatric side effects. We're hearing about people's lung not coming back. We're hearing about emphysema. So I think that I wouldn't worry too much about that at this point. And I give you an example. In the case of rabies, you give antibody and the vaccine at the same time. And the vaccine still works. So what I would say, don't worry about it right now. If you have somebody, use it. And then when the vaccine is available, you get the vaccine.
Okay. What are your opinion about the combined use of convalescent plasma associated with mesenchymal stem cells?
Oh, well, one of them is really experimental. We haven't had any experience with that. But I think that, this is a very complicated disease. And I think that you're going to need multiple layers. You're probably going to need antivirals. You're going to need antibodies. And I think the more options we have, the better. And if we can combine them, we're probably going to be able to reduce mortality much more.
So do you think that's possible to use with antiviral drugs, for example?
Oh, yeah.
in combination with.
Yeah, absolutely. They work totally different. You know, one is working at the immune system, the other one is working at viral replication. I think that they would not be antagonistic. At best, they would be synergistic or additive.
Okay, another one is if human genetic factors influence the response for SARS-CoV-2, can you think that infection diseases are also genetic?
So,
a good question.
You know, we live in a genetic era, right? So everybody wants to find the genetics of this. I think that there is probably going to be a genetic component. I actually wrote an article about this, but probably, you know, what other things may be more important. I mean, the inoculum. How big was the inoculum when you got infected? How was your immune condition when you got infected? Did you have history with other coronaviruses? So I think genetics is going to be important, but in something like this that is affecting so much of the population, you may find some alleles that gives you a couple of percentage, but I think luck is more important.
One point that they are talking about is the HBO type of blood. And the A type is the worst. And I am A type.
And I am A type too.
I'm A type too. I'm A type too.
What do you think about it?
You know, so A type, as you know, it reflects the immune response in many ways to bacteria in the gut and things like that. I think that there's probably maybe some association. Look, this disease is an immunological disease. You get sick because the immune system is so strong that damages your lung. So there is almost certainly going to be some, you know, immune correlates. And given that the ABO blood types in many ways reflect our response to bacterial antigens, probably. I just wish that I was type O if I got this.
Yeah.
Yes, my husband and my daughter is type O, so they are safe.
In my house, all of us are A positive, so.
Another question here, if there is, as we are talking about blood types, if it is any way to minimize the risk of transfusion reaction, do you apply anything to minimize this?
So it's already, Andrea, it's already extremely low. You know, with mother transfusion factor, I mean, you probably have less than 1 in 100, and most of the time, the transfusion reaction is that they get hives or they get itching. And what you do is you give them a dose of cortisone and or a steroid, and it pretty much goes away. So I was much more worried about infusing antibody into them, you know, forming antigen-antibody complexes, and that causing, you know, a
necrotic disease.
Exactly. Yes. But no, just it doesn't happen.
So there is another question, just trying to, because it's a lot of questions coming to us. This is another question concerning about those Chinese work that talked about how many time the antibody response lasts in a patient. How do you think these results, influence the plasma therapy? Because they talk about how long it lasts at all, and neutralization too. So.
Yeah. So it looks like the stronger, the more severe disease, the more likely you have a very strong response. So people who are asymptomatic don't seem to be making very strong responses. But again, there's variable. You have some asymptomatic people making lots of neutralizing antibody. I'm very impressed by the variability. And one of the things that's happening here in the United States is that all the blood donors are now being screened for antibody. And the units that have any sort of antibody first are being used for plasma, for gamma globulin. But it looks like, you know, there's a lot of variability. I think that we're all responding very differently to this. I suspect some people may be getting rid of it with innate immunity and IgA, and they don't have a lot of antibody, and you probably don't mount a strong antibody response unless you have systemic disease.
So I think that the principal questions we ask for you. So the other questions we will send to Andrea Nicola, that works here in UNB with the convalescent serum. He has a group that is working. So I think that he can answer the other question.
Say hello to Andre.
Yes. And Arturo, very, very thank you to agree to talk with us. It was a very nice talk. I think
an honor for us to have Dr. Arturo with us.
It's good to reconnect with friends in Brazil. Yeah. My plea is that if you make observations, to write them up quickly. Okay. It really helps, even if you put in a preprint. The preprints, forget about publications. We are living on preprints.
Okay, and I think that it's a pleasure for me too, because I spent a very nice time in your lab during my year in New York. So thank you very much to join us in this project, because we are starting today this project. You are the first one.
Yes.
Well, thank you.
Yes, thank you.
All right.
So very nice talk. Everybody is just getting huge comments. Thank you very much. And for the students, pessoal, caso a gente não tenha respondido suas perguntas, pode mandar ou pelo nosso e-mail.
Thank you, Arturo.
Nosso e-mail, tá? Nós iremos responder, tá? Ou com a Andrea Nicola, ou endereçando ao próprio Arturo. A gente tentará. Não se esqueçam que na página da disciplina, a gente tem um fórum de dúvidas, tá bom? Muito obrigada. Em breve anunciaremos o nosso próximo seminário. Obrigada, Ana Amélia, por fazer a moderação, tá? Muito obrigada a todos. Acabou, Givas?